Right guys, see this question. The output of a transformer at full load unity power factor, the given unity power factor 400 kilowatts. 400 kilowatts. What is the output at 0.8 lagging? Whatever, 0.8 off load. 0.8 power factor off load, the power output will be how much? How we can calculate? Actually, the transformer rating should be represent. Actually, the transformer rating should be represents in what, sir? kVA, right? So let's take first kVA. What is kVA, sir? The kVA is nothing but kilowatts by power factor. Kilowatts by power factor nothing but 400. So the transformer kVA is a 400. At full load, the kVA is the 400. Then what is at off load? Then what is at off load? The kVA at off load 200. The kVA at off load 200. But the answer will be in terms of kilowatts. Then what is kilowatts? Kilowatts is equals to kVA into power factor. kVA into power factor, that is 200 kVA into power factor 0.8. So what will be the answer, sir? 160 kilowatts is our answer. So don't judge with respect to kilowatts. If they are not given power factor, then consider unity power factor and try to solve the answer. If the unity power factor given, of course kVA and kilowatts both are same. Right, sir? Let's go for next. A 25 kVA single phase transformer 2200 by 220 volts has a primary resistance of 1 ohm and secondary resistance of 0.01 ohm. Secondary resistance of 0.01 ohm. Find equivalent secondary resistance R02 they are asking. R02 is equals to R2 plus R1 dash. R1 into K square. R2. The secondary resistance 0.01 and R1 is a 1 into K square. What is K? K is equal to N2 by N1 or E2 by E1, which is equals to 1 by 10. 1 by 10 square, 1 by 100. So this is 0.01 plus 0.01. 0.01 plus 0.01, which is equals to 0.02. Simple question, sir. Next, 100 kVA transformer has an iron losses of 100 watts. Iron losses of 100 watts and full load copper losses. Full load copper losses of 400 watts. Full load copper losses of 400 watts. Calculate kVA at which the efficiency is maximum. Where we can get the efficiency maximum? At maximum efficiency, kVA is equal to, what is the formula? X into full load kVA. X into full load kVA. What is X? Square root of iron losses by copper losses of full load kVA. Full load kVA. This is the 1 by 2 of 100, which is nothing but at 50 kVA. At 50 kVA, we will get the maximum efficiency. Simply, at what load we can get the maximum efficiency? At off load we can get the maximum efficiency. At off load nothing but full load kVA 100, off load kVA 50. That's it. Next, what is the answer for this? A transformer core has air gap. We already discussed, if air gap length increases, reluctance increases. If reluctance increases, flux reduces. In order to maintain flux constant, the transformer will draw more I mu, but there is no change in IW. There is no change in IW. Where I mu increases, I naught increases, and the power factor will reduce, we discussed. Yes or no, guys? If this is a supply voltage V, if this is a flux phi, if this is what IW, if this is what our I mu, sum of IW, I mu is taken as I naught, and this is a power factor angle phi naught. But when the air gap increases, ultimately IW constant but I mu increases, then I naught increases, then phi naught increases. When the phi naught increases, the power factor will reduce. So, if air gap increases, reluctance of the magnetizing path increases. Hysteresis losses decreases. Hysteresis losses will be changes actually, but not decreases, maybe increases. Next, magnetizing current greatly increases. Magnetizing current greatly increases. Eddy current losses increases. They may not, we can say directly, but here magnetizing current increases directly. Okay guys, so this is simply what about the transformer. Transformer has air gap. Here, if you want to choose only one answer, then go for magnetizing current increases greatly. If you want to go for more than one answer, this is wrong answer actually. And hysteresis losses doesn't decrease, it may increase because flux increasing. I mu increasing. Of course, we are maintaining the flux constant, of course, even though these are the wrong answers. We are maintaining the flux constant actually. Okay, so the magnetizing current greatly increases, but the IW, they may give you IW increases, wrong answer. Power factor increases, wrong answer. Power factor decreases. Power factor decreases. Actually, this is very important. In the options, they will give you first statement and second statement and third statement and the fourth statement. Then choose the correct statements. They will ask you like this. Next, a transformer has efficiency of 85% and works at full load 100 volts. Works at 100 volts. Works at 100 volts. 4 kVA. 4 kVA. If the secondary voltage is 200 volts, secondary voltage is 200 volts, then the primary current, transformer has an efficiency of 85% and works at 100 volts, 4 kVA. If the secondary voltage is 200 volts, find the primary current. Primary current I1 is equals to 4 kVA by primary voltage. By primary voltage, ultimately the current is 40 amperes. Ultimately the current is 40 amperes. The primary current is equals to power by E1, that's it. Next, a 230 by 2300 volts transformer, no load current they given, no load current 5 amperes and the no load power factor they given 0.25. The core loss is, they are asking IW. They are asking W naught. They are asking core losses, not a core loss component. Core losses. So W naught is equal to V I naught cos pi naught. V I naught cos pi naught. V, which V we need to take? The open circuit test should be conducted on LV. On LV, 230 volts into 5 amperes into 0.25. 4 ones are, 4 fives are 20, 20, 30. 30 is there. So what is the answer? 4 sevens are 28, 28.5. So 50, 55s are 250, 5 sevens are 35, 5 into 0.5, 2.5. So the answer is how much, sir? The answer is 287.5 watts. 287.5 watts. Next question. A 220 by, see this, a 220 by 110 volts 50 Hz transformer, connected to the supply on high voltage side. High voltage side, they are giving the supply. If it is operating at primary voltage of 220 volts, if the primary voltage is 220 volts and 5% less frequency, actually if they given you only frequency, don't change the EMF values. It will be corrected in somewhere actually. So If they given only 5% change in frequency, 10% change in frequency, the EMF won't changes actually. The flux may increases, flux density may changes like that. So here, if the primary is 220, the secondary is 110 volts ultimately, even though frequency changes. And next one, operated at primary of 110 volts. Which side? High voltage side, they given 110 volts. Nothing but 50% of this. Here also you will get 50% because N2 by N1 is equal to E2 by E1 same. If here voltage applied is off, here also off. So this is a 55 volts. First case 110 volts, second case 55 volts. Even though frequency reduces. Okay, in first case it is called E21. In second case it is called E22. Now what they are asking, E21 by E22. E21 by E22. E21 by E22 is equals to 2 times. Is equals to 2 times. Next. Next, come on. A 3:1 transformer. K is equal to 1 by 3. 3:1 nothing but N2 by N1 K. N2 by N1 K. Has a impedance of 1 plus J5 on primary and 9 plus J45 on secondary. 9 plus J45 on secondary. The total impedance on HV terminal. HV terminal nothing but primary side. Now they are asking Z01. They are asking Z01 primary side, HV side. Z01 is equals to Z1 plus Z2 by K square. Z1 plus Z2 by K square. Z1, 1 plus J5. 1 plus J5. Sorry, here small mistake. Sorry, here small mistake. What is a mistake? What is a mistake? This is a Z2, this is a Z1. Why? See, this is LV, this is HV. This is LV, this is HV. Who is LV? Secondary is LV. Who is LV? Secondary is LV. Secondary, LV, LV. Secondary is LV. This is HV. HV is a primary. They given that. This is primary. Now we want primary side total impedance. Primary side total impedance. How much? Z01 is equal to now Z1 9 plus J45 multiplied plus Z2 1 plus J5 divided by K square. What is K? K is a 1 by 3. K square 1 by 9. 9 will come. So this also how much? 9 plus J45 plus 9 plus 5 nines are J45. So this is our answer. 18 plus J90. 18 plus J90 is your answer. 18 plus J90 is your answer. Next. Actually, this is again same question. Actually, this is again same question. Something is missed here. And next, a single phase transformer has maximum efficiency of 90%. The maximum efficiency is 90% at full load. This maximum efficiency occurs at full load. This maximum efficiency occurs at full load and unity power factor. Then efficiency at off load and same power factor. Efficiency at off load and same power factor they are asking. Let's see the efficiency at full load. The efficiency at full load is 90%. That is full load kVA into power factor. Full load kVA into power factor by full load kVA into power factor plus full load kVA into power factor plus iron losses plus copper losses. Iron losses plus copper losses. Because the power factor is 1, multiply or not, no problem. Iron losses and copper losses are equal because at maximum efficiency. So what is kVA from this? What is kVA from this? At off load they are asking. So these are gets cancelled. So 9 times of kVA plus 18W plus 18W is equals to 10 times of kVA is equals to 10 times of kVA. 9 times of kVA is equal to 18 plus W is equal to 10 times of kVA. What is 1 kVA? So 1 kVA, this 9 will come here, 10 minus 9. 10 minus 9 is a 1 kVA. 1 kVA is equals to 18 W. 1 kVA is equals to 18 W. This is what our full load kVA. This is what our full load kVA. Now let's calculate efficiency at half load. Efficiency at half load is equal to half of the full load kVA into power factor by half of the full load kVA, half of the full load kVA into power factor plus iron losses plus copper losses by 4. Why by 4? Because they are asking at half load. What is the half of the full load kVA? Full load kVA is 18 W divided by half of the full load kVA plus W by 4. How much, sir? 9W by 9 plus 1, 10. 10 plus W by 4. 10W plus W by 4. Almost 41W by 4. 41W by 4. This 4 will come. Nothing but 36W by 41W. 36W by 41W is your answer. Just I calculated full load kVA. Full load kVA 18W I substitute. Iron losses won't change from full load to half load, but the copper losses will change up to half load nothing but by 4 because 2 square 4. So W, this is 9W plus W, 10W plus W by 4, which is 40 plus 1, 41W by 4, and numerator is 9. 4 9s are 36. 31 out of 41. Sorry, 36 out of 41. How much? All our approximate answers are there. We need to calculate clearly. 0 point nothing but that is 360. 9s are 8s are. 8s are. So 8s are 4 8s are 328. 328 nothing but 32 will be there. So 0.8 and already point is there 0. Again not 8s are 7s are only. Not 8s are 7s are only. Because if it is 8s again we need to take 328. But there is no 328. We have only 320 here. 328, 320, not possible. That's why I taken 7s. That is your answer. You can calculate.